Your coding agent just got flagged as a hacker. Not because it did anything malicious. It ran a command. It decrypted some browser data. It wrote a file to a folder that runs automatically on startup. Routine work, the kind you assign it 50 times a day without thinking twice. Last week, security researchers watched a coding agent get flagged as a hacker for doing exactly that. If you're a developer in the US or the UK running Claude Code, Cursor, or OpenAI Codex right now, this has probably already happened on your machine. You just haven't seen the alert yet. What did the agent actually do to earn it? That should feel like a small bug report. It isn't. But the real story is what that alarm reveals about how security software actually works. It was never built to detect hackers specifically. It was built to detect a shape, a pattern of actions a computer takes when something is going wrong. And it turns out your assistant makes that exact shape on a completely ordinary Tuesday while you're getting coffee. You are watching the Tech Tales. Take a second, hit subscribe, and let's get into it. Watch this number. This is one security vendor, 1 week of its own machines. Sophos pulled 7 days of endpoint telemetry from its Windows fleet, counted by how many individual machines tripped a rule, not by raw alert volume, and checked what was actually setting off its detection engine. It wasn't ransomware. It wasn't a phishing kit. Almost all of it traced back to 3 names you already know, going about their normal jobs. Here's what tripped the wire. More than half of it was agents reaching for stored secrets, what defenders call credential access. Another large share was execution, agents running code the exact way an intruder would. Of the credential access alerts, the single biggest slice, well over 40%, came down to one specific move. Why would a coding assistant need to touch your saved passwords at all? This is what the terminal is actually watching for. Windows keeps your browser's saved logins locked behind something called DPAPI, a built-in decryption layer. Only certain processes are supposed to ask it to unlock that vault. When something does, a well-built detection engine treats it as one of the loudest signals available. Because for years, almost nothing legitimate ever asked for it. That single assumption held up for a long time. You'll see this chain. One coding agent's browsing skill, a widely used add-on called GStack, calls that same API to pull saved login data, so it can act inside a browser on your behalf. Researchers caught this running under Claude Code, not stealing anything, automating a task you gave it, probably a form you asked it to fill out. To you, it's a shortcut that saves 10 minutes. To the machine watching underneath, it's indistinguishable from theft, because structurally, it is the same request. Some examples looked worse on paper than they turned out to be. In one instance, the same kind of agent shut down the browser that was already running, then executed a script that pulled data straight out of its credential store, before separately running a built-in Windows command to list out everything the operating system's own credential manager was holding. It was working with a permissions flag switched on that its own maker's documentation actively warns administrators against enabling, precisely because that flag removes the checkpoints that would normally have made a human confirm each step first. Nobody had to break in. Somebody just turned off the thing that would have stopped this from looking exactly like a break-in. Watch what happens when the first attempt gets blocked. In one case, an agent tried installing a package using a legitimate Windows tool called CertUtil. Security software shut it down. So the agent tried again, this time with a different built-in tool called BitsAdmin, and got through. Nothing it fetched was harmful. But that pivot, try one door, get blocked, quietly try another, isn't what a static script does. It's what a person does under pressure. Specifically, it's what an attacker does the moment their first move fails. That single retry is the whole trick. It's the same adaptive behavior that identifies a real intruder to a trained analyst, and a coding agent just performed it by accident, trying to install a package for you while you were in a meeting. If this is making sense so far, the like button helps more than you'd think. Moving on. Here's the number that explains why this happened in the first place. A widely cited industry threat report found that the overwhelming majority of confirmed intrusions last year involved no malware file at all, no virus to scan for, no signature to match against a database. Attackers had already moved to valid logins and ordinary system tools, the same ones sitting on every machine already. So the entire security industry pivoted over several years at real cost. Detection stopped asking whether a file was bad and started asking whether a behavior looked bad. That pivot worked for a while. What happens when the thing generating the behavior stops being human? Then agentic coding tools showed up and started generating that exact behavior, legitimately, thousands of times a day, across a fleet of machines nobody had budgeted extra alert review time for. This is the exact signal defenders spent years building their entire system around. Now, two completely different sources produce it. A person trying to break in and an assistant trying to help, using the same commands, the same APIs, sometimes the same retry logic. A month earlier, the same research team caught an attacker running an AI model to do the opposite job, coordinating the construction of malware specifically designed to slip past detection software, using a frontier coding model to help write and stress test it against real endpoint products. Same category of tool, opposite side of the fight. Offense and defense running the identical class of software, and the alarm sitting in the middle has no way to tell which one it's looking at. And this is the moment the entire model quietly breaks. A detection system built to answer one question, is this action dangerous, was never designed to answer a second, harder one. Whose hands were actually on the keyboard when it happened? It doesn't know. It has never had to know. Right now, for the first time, that gap is the whole problem, and nobody upstream has shipped a fix for it yet. That same alert is probably sitting in your own logs already, filed away as noise, dismissed by whoever's on call this week because it came from a tool with a name they recognize and trust, which is, on its own, a decision worth questioning. A rule doesn't get gentler just because the thing tripping it has a friendly product name attached to it, or a subscription your company already pays for. Here's what defenders are actually doing about it, at least the ones paying attention. Scope the noisy stuff. Retried downloads, oddly formatted scripts, to the agent's own parent process, so ordinary automation stops flooding the same queue used to catch real intrusions. But hold the line completely on credentials. Decrypting a browser's saved logins doesn't become safe because an assistant did it instead of a person, and an agent shouldn't inherit blanket access to a credential store just because it's running under your login. If anything, this becomes a policy question nobody has fully answered yet. What should a coding agent be allowed to touch on your machine at all? And who actually decided that on your team? None of this makes your coding agent dangerous. That was never the finding. The finding is quieter and considerably harder to fix. The industry spent years building tools that judge you by what your hands do, on the fair assumption that only you would ever be doing it. That assumption just quietly expired, sometime in the last few weeks, and almost nobody has updated the paperwork to reflect it. So here's the idea this video actually proved, underneath the story about one vendor's alert queue. Security built around watching actions assumed the actor was always human, and every rule, every threshold, every "this looks suspicious" was calibrated against that one fixed variable. That variable isn't fixed anymore. The uncomfortable part was never that your assistant sets off alarms. It's that the alarm was never designed to ask who or what was actually behind the keyboard. And it still can't answer that question tonight, for you or for anyone else running the same tools you are. If you made it this far, you're a champ. Subscribe, and see you in the next one.